Hello and welcome to How to Arduino 6. In this video, I'm going to be covering how to use Tinkercad to simulate Arduino programs, and then we're going to go over motors and servos. If you'd like to see some of the other videos in this series, you can check the link in the upper right underneath the little I or in the description below. So with that said, let's jump right into it. In order to use Tinkercad, the first thing you need to do is go to tinkercad.com. That brings you up to this website. Now there's two things you can do. You can either join now or sign in. If you already have an Autodesk account, like if you have AutoCAD or Fusion 360 or Inventor or any of those, click on sign in and then use your information to sign in. It's all the same thing. If you don't have an account with that, then you need to click join now. Brings you here, create a personal account, and then move on from there. Fill it all out and set it up. Once you're signed in, this is what the screen looks like. On the left-hand side, you see your profile stuff along with the different sections you can go to. On the right-hand side, you see normal links and links to your profile, all that stuff. For doing Arduino stuff, we're interested in circuits. You click on that, and then it brings up, for you it should be blank, but I already have some, obviously. Then, if you want to make one, click on Create New Circuit, and it brings you into their circuit builder. For this, we'll just build a simple blinking circuit with an Arduino, because that's what we're concerned about. So I'm going to search for Arduino. It has the Arduino Uno R3. Put that in there. We'll throw in a breadboard as well, just to show you how it works. Then I'm going to connect my breadboard to my rails. I like that make things nice and square. There we go. So once you make the wires, you can then change the color, or you can change it when you put them in. So I'm going to make red for my power and black for my reference or ground. Then I'm going to put in an LED. If you want to rotate a part, you can do so by pushing R, and it rotates in chunks. Now, the anode's on the right, so I'm going to connect that to my positive, and then I need to have a resistor. I turn that just for fun. I'm going to connect it to the cathode, and then it's going to go to ground. Change the colors to make that make sense. I don't like to have power be green. And then to change the value of the resistor, you click on it and you tell it what value to put. I'll make it 470 ohms. You can also change the name. It changes the color in real time, which is nice. Click on the LED, you can change the color. I want to make it a green LED because I can. Then, if I were to run this right now, it just turns on the LED. That's fine. We're just using this as a power source. It's not really exciting. So we'll change what we're doing a little bit, and instead we'll use we'll use 13. It's always a good number. And I'll make that one orange. So I hook up the LED to pin 13. And now to write the code to make things actually happen, I click on code. Tinkercad has this block system. I don't like it. So I'm gonna go text, click on continue, that just deletes everything that was there, and now we see what actually is the Arduino code. The default code that it has is a blink on pin 13. Hey, check it out, we're in pin 13, perfect. So let's use the default code, but this is where you write the code. We'll get into that when we actually do the motors. Click on start simulation, and we have a 1 second blink of our LED. I forgot the word LED there for a second. And then at the top, you can see the simulator time. It's probably not going to run in real time for most things, just because of the fact that it's going to take some work to do things and run over the web and all those other things going on. If you happen to have more than one Arduino in your code, you can choose which one you are programming by this little drop down over here on the right. You can also share your code with people. So you can share it and invite people and do all those sorts of things. You can export your code. Click on that again to stop the simulation. You can then hide the code, bring it back, whatever, it doesn't matter. So that is a very simple introduction to how to start tinkering with circuits. Next, we're going to get into how to run a DC motor. Okay, so before we get into programming the motors, first, I want to go over DC motors a little bit and the Arduino and some of the limitations of the Arduino. So first, we're going to show a motor here with absolutely no Arduino. This is just 9 volts feeding into a 5-volt rectifier, so we get 5 volts out coming into our motor. I change it to 5 volts only because this way it's a fair comparison when we start using the Arduino for the same thing. We have the same voltages everywhere. This meter on the left I have set showing the voltage to show that it's 5 volts. This meter on the right I have showing the amperage going through the motor. So let's start the simulation and see what happens. So if you haven't seen this before, on the motor itself, it shows the direction it's spinning by which way the gear is going, and then the RPM is written underneath. So we're going at 9,991 RPM. We're drawing, call it 80 milliamps, and we have exactly 5 volts. So what happens then if we hook up the motor directly to the Arduino? So, being well prepared, I've already done that, it's over here. So now we have the exact same thing, except we're pulling 5 volts straight from the Arduino. This again is measuring the amperage, and the motor will tell us the RPMs. So we start the simulation. We see we have 9,994, which we're gonna call the same thing. It's roughly 10,000 RPM at 79.9 milliamps or 80 milliamps. It's exactly the same. Now this is actually what we should expect because the 5-volt regulator that I used on the other example is the exact same 5-volt regulator that they use on the Arduino to give you 5 volts. So good deal, we get what we expect. This isn't really helpful though because we probably don't want the motor to spin at full speed all the time. So then what happens when we hook up the Arduino to one of the digital output pins and we tell it to run at full speed? Once again, I'm prepared. So here we have the most obvious way that we would run it. We hook up the Arduino to one of the PWM pins and we tell it just to turn on, right? That's all this is doing. So we start the simulation and it's 5,555 RPM at 44.4 milliamps. Okay, so let's compare that to the other one. We're going from 80 milliamps to 44.4 milliamps. Okay, so that's not right. Is this just an artifact of the simulator? Is this something the simulator's not good at? So here I have overlaid a recording that I took of my multimeter using the actual motor in this exact same setup. And you can see, again, it's extremely limited. We're not getting out nearly as much as we should be in order to run this motor at full speed. And so in order to find out why don't we go to the official Arduino Uno website, and then we can scroll down a little bit, click on tech specs, and you can see all of the important information about the Arduino. See the input voltages, the input voltage limits, analog input pins, and then here we get the important one, which is the DC current per I/O pin. And it's only supposed to be 20 milliamps. This thing is only designed to give 20 milliamps out of its input-output pins. So the fact that we're actually getting 45 to 50 is, 2.5 times more what it's supposed to be supplying. But it's still not good enough because as we can see, this motor here, we'll just use the simulated one, wants 80 milliamps, which it's 4 times more than what the Arduino can supply. So in order to supply the amperage that we need to for the motor, we're going to have a little bit of additional circuitry and run it a slight different way. In order to set up and run our motor, first we're going to need to create a new circuit, and that brings us to our blank page. We're going to put in an Arduino, so I'm going to type it in. I like to type in what I'm looking for as opposed to scrolling through. You have the option to scroll and do whatever you want, but you can also click on Components, All, and then you can see everything that's available inside of Tinkercad. However, for me, it's just much easier generally not to do it that way. Next, I'm going to bring in a breadboard just to give us a place to put things and make our life a little bit easier. I'm a little bit anal about the way I like to set things up, so I'm going to be a little careful and put it in the right place. Next, I'm going to get our DC motor. Just straight up DC motor. This is what it looks like in Tinkercad, and this is what it looks like in real life. I do suggest that if you have the ability to build these circuits in real life, simulating is great, but it's not nearly as good as building it and actually touching it and having things work. I feel like you learn more tactily from actually building the circuit and doing it the way we've been doing it. However, now I know it's difficult for everybody to get their hands on things, and simulating is a decent alternative. So now that we have these basic parts, we'll just set up what we need to have. I'm going to give it 5 volts. So first I'm going to drag my 5 volts out this way and then connect it up. And I'm going to set things at right angles because I'm anal like that. And I will make it red. So find it, there it is. There's red. Now the ground I will make black. One reason I'm being so particular about colors is because I'm yet to find a decent way in Tinkercad not to cross lines, and keeping colors the proper things makes it easier to tell. So here you can see that the red and the black aren't actually sharing anything because they're different colors. So that is one reason why I'm so picky. The next thing I want to get is a transistor. So I type in BJT and I want to get an NPN transistor. In your kit, that is the 2N2222 transistor, which looks like this. Now I put it into the breadboard, and I'm going to try not to zoom in and out. I have a tendency to want to zoom in and out on things a lot, so I'm going to try not to do that. So first thing I'm going to do is I'm going to hook up the power. Then the output of the transistor, which is the emitter, is going to go to the positive of the battery, which is red. I'll keep the same color notations. And then I'm going to need to control the transistor. So to do that, I'm going to hook it up to, well, we'll call it pin 10. It really doesn't matter. We want to get a PWM pin for this, just so we have the option of not sending full values if we want. So any of the PWMs will work, but in this case, I'm going to use 10. And I'll make that yellow. I'll try to make sure that I keep the colors of the data transmission lines different than the power transmission lines. Next, I need to connect my motor to ground. Keep that black. And now we have this hooked up. This is going to be our circuit. The way that the transistor is going to work is it's just going to be a switch. So nothing will travel through it unless it gets base current. We send it base current from the Arduino, and then that turns on the motor. So I like to think of BJTs especially as guitar strings. You attach it to power on either side, and then you pluck the middle of it. And plucking the middle is what causes it to actually do things with the entire string. So you get the sound from the entire string by giving a little bit of effort to the middle of the string. In a transistor, you put the power through the outsides of the transistor, and then you get to control that power by playing with the middle of it. Maybe not a great analogy, but I don't know. It seems to work in my head. So now we need to get code. We're going to go here, go to text, because we don't like dealing in these weird blocks. I just feel like they're not nearly as powerful, and it's not as intuitive for me. So now we need to actually set up our code. The way that we're going to do that is the same way we always do. We'll call a constant, integer. I'm going to call it motor pin. And that's going to be pin 10. Then when we get into our setup, we need to do a pin mode, motor pin, output. Now we can do a analog write. We're going to send it a, you know what? Let's start with doing a digital write, just so we can get an idea of how it works. So digital write, motor pin, high. All we're going to do is just set it to high, and it'll set it to high every time it goes. So that's what we'll do first. And that's it. We will simulate, and we see that we are getting, it's probably hard to read, but it's 8,482 RPM. That is really close to our initial 9,999 RPM that it's trying to get to. So I consider that a success. If we're curious, which I know I am, we can then look in here and grab a multimeter. Grab a multimeter, come up here, and we'll just do the same thing I had set up before, where we interrupt the ground leg. I have emails coming in and my dog barking in the background. I apologize. So we interrupt the ground leg, we'll make it black. It's not gonna be nearly as pretty because I'm stopping. It's not gonna say I don't care, but it's definitely not as important at the moment. So we set that up, we start the simulation. This is our amperage. We have 67.9, which is compared to our 74.9, I think it was earlier. Definitely much better. And we, no matter what with the setup, we're not going to have it exactly the same because we're going to lose some through the transistor. So this is how we will control our motor. And that's the thing, is right now we're not controlling the motor, we're just turning it on, right? Now that's not super impressive. We could do that without the transistor and the Arduino, so let's not do that. So now we want to actually do something with it. So what we can do is we can turn off the simulation, come in here, and then let's just say we do our standard deal. We delay for a second, and then we turn it off, and then we delay for another second. Okay, so there's this. This should work. It goes for a second, turns off, and it goes. So if you want to do it that way, that's an option. There's different situations when you might want to do this. What if we wanted to change the speed? Okay, so we have a PWM signal pin, so that we could use PWMs. Instead of digital write, we can use analog write. And instead of high and low, we give it a value. So we can say 255, it goes full speed. And then we can do, say, half speed, right? So once again, if you don't remember, the way that analog write works is that you give it the pin number that it is sending it out to, and then a value from 0 to 255 of how much voltage it is going to send. So if we run this, it goes at full speed for a second, and then it goes at half speed for a second. And you can tell a little bit better from the amp meter because it's pulling half as much amperage, but if you look really closely, you can see it's going from 4,400 to 8,500 RPM. So it's going from half to full. Okay, but what if we wanted to have an input that controlled it, which would be much more interesting? Well, we can do that. How about we use the potentiometer? It looks like this on the Tinkercad, and in real life, it looks like this. And then what we're going to do is we're going to put this into our breadboard. It is a 10K potentiometer. So, I mean, technically it doesn't really matter what value you use for this because of the way we're using it, but whatever, we'll put the right value. And then what we need to do, again, I'm trying not to zoom in and out a lot. The middle leg of the potentiometer needs to go to, well, use A1. It needs to go to one of the analog inputs. And we will use orange for that because it needs to have a color. And then the outsides get voltage. So we just send it to plus and minus. Make that red and make this black. So we now need to add code to work with this. So we're going to have another constant integer. I'm going to call it pot pin for potentiometer pin. And that is now going to be A0. I'm going to set a pin mode for it, and it's a input. Then I'm going to have a value that's going to be assigned to that potentiometer. I'm going to declare that up here. So it's going to be an integer, and we'll call it val for value. Down here, we will go and val equals analog read. And that needs to be the pot pin. Next we're going to have to do is we're going to have to turn this value, which as it comes in from the potentiometer is between 0 and 1023. If you don't understand this, go back and check the sensors video, which goes over the analog read and write a little bit in more detail. We don't want it between 0 and 1023. We want it between 0 and 255 because those are our output options. So we're going to use a function called map. So we'll say value, we're just going to call it value again. It's going to make a new variable, equals map. And we're going to have to then tell it which value we want it to map, which is going to be called val. We need to tell it the range that the values can be. There's going to be 0 to 1023. And then the values that we want it to be between, which would be 0 to 255. This does the math for us and sets it. So we now know that if the value of that's read on the potentiometer is 1023, it will come in and this will change it from 1023 to 255. If the value is right in the middle, right at 566, shouldn't do math live like that, but it should be close enough, it will now come out as 128 and so on and so forth. So it fixes it for us. With that, we don't need to have to do the math, and all we can do is pass in the value. So let's try that. Close the code, start the simulation, and we realize that we have an error because input is not a thing. So this is what it looks like when you get an error in Tinkercad. I did not do that on purpose, but it works out pretty good. It looks the same as it does in the Arduino window, but it gives you this, it seems like your code has some errors, which is new. I don't know, whatever. So now we can run it, and we see that we have 30 milliamps at 4,000. And then if you want to change a value, and this does absolutely nothing, so this does absolutely nothing. There's a reason. Why does it do absolutely nothing? Okay, so if you look at our code, we see right here we have pot pin as A0. I hooked it up to A1. So it's going to be confused and not work right. Imagine that. So I'm gonna go through, change it back to change it to A1, start the simulation. And now we see, as I turn it all the way to the right, it stops the motor. If I put it about halfway, it gives us our 33 milliamps and back to 4,000 RPM. And if I turn it all the way to the left, whoops. If you click on the outside of the ring, you get to change the potentiometer. I don't want to do that. You need to click on the inside of the ring to move it. All the way to the left, I get full speed. So that is how you can simply run motors using an Arduino. The next thing we're going to cover is how to work a servo. And we're going to do that one a little bit differently than we have before. I'm not going to walk through the entirety of everything because I think we're past the point where we need to do that. Like I said in one of the earlier videos, I'm going to try to pull back on the abstraction over and over again, so as we can go, I can cover more complex topics without having to walk through every last step. So we're going to try that now. First thing you need to do is open up the servo example, and then I'll bring it over in here. So here's our servo example. This should look pretty familiar. The servo looks like this in Tinkercad. It's called a micro servo, and it looks like this in real life if you have the actual kit. We have the potentiometer again. It's the same one we had before. We hook the Arduino to the power rails. The potentiometer is hooked up in exactly the same fashion as it was just a second ago, except this time it is hooked to A0 instead of A1. And the way that you figure out which is which for the servo, which is nice in Tinkercad, is it actually make me not make this mistake, but orange is signal, so that's the one that goes to your Arduino. Then red is power, and brown is ground. That is the general servo convention for colorings. I've kept the same colors on the schematic as well. Now we can look at the code. This is where things are going to change. I've shown you schematics before, but I've never just shown you finished code, but I'm going to this time, and we'll just walk through what everything is so you don't have to listen to me type. So here's our code. The first thing we need to do is do an include statement. We covered those in the sensor video. It's important here as well. So we're going to include servo.h. Next, we're going to create a variable that will hold the servo. Kind of like we had to build variables that held onto our sensors before. Same thing, except now it's an output. So that is a capital S servo, and then I call that variable my servo. Then, as I did a minute ago, I create a val integer that will hold the potentiometer value. I set constant ints for the servo pin and the potentiometer pin. Now, inside of the setup, we don't have any pin modes. I've been using pin modes for analog inputs so far. You don't have to. The analog inputs are actually separate to where you don't need to do that. You only have to set a pin mode for digital. I've been doing it thus far to keep consistency so it wouldn't be confusing. This time I decided not to in order to show you that you don't need to do it. So now inside the loop, we know where the magic happens. First we do a analog read of pot pin, just like we did last time. Then we do a map. Now last time we did a map from 0 to 255. This time we're doing a map from 0 to 180. And the reason for that is because you input a degree that you want on the servo, and these servos can move 180 degrees. So this way we can set it so if we wanted to go to 90 degrees, it will just go to 90. That's all that is. In order to make the servo move, we use a function called myservo.write, and we put in the value we want it to move to. And then there's a small delay so things don't go too fast. So let's take a look at it. It immediately jumps to the 90-degree mark roughly because that's where the potentiometer was. And now as we move this, it correspondingly moves the servo. And we can bounce it around like that. Servos are very handy because they are often used for animatronics. Anytime you need to move something very specifically, it's kind of like a stepper motor, but not really. We're not going to get into the details of the motor itself. We don't have enough time. But especially if you want to change linear or rotational to linear motion. So say you have an RC plane is a really good example. I use servos a lot. In that, you have the servo motor wanting to spin, but you want to move the flaps. So what you do is, let's put this way to start, you connect a rod to the tip of the servo, and then the other rod to the flap on the airplane, and then that way when you move it, it pushes and pulls the rod and moves the flap up and down. So the exercise that I want you to do for this video is I want you to go in and build this circuit exactly as it is, either in Tinkercad or preferably with your actual components. And that's it. This is actually a very simple one. It's just to get your feet wet in Tinkercad, and we're going to start with this alone. Next time, we will get into a little more detail inside of Tinkercad, hopefully. So thank you for watching. If you want to see any of the other videos in this series, you can find a link in the description as well as in the eye in the upper right hand side. With that, good luck on your exercise, and hopefully I will see you next time.